What if the first warning sign of disease was not pain, but a pattern hidden inside your data? Before a doctor hears symptoms, before a scan looks dangerous, AI may already see something changing. This is not science fiction. It is one of the fastest moving revolutions in modern medicine. The problem is that many deadly diseases begin quietly. Cancer can grow before pain appears. Heart disease can build for years before the first emergency. Parkinson's may begin changing the body long before movement becomes visibly different. Doctors have always searched for clues. First with touch, then with microscopes, then with X-rays, blood tests, and genetic sequencing. But the amount of medical data became too large for any human mind to read completely. That is where machine learning entered the room. AI does not get tired. It can compare one patient against millions of patterns learned from images, signals, notes, and lab results. A tiny shadow in a lung scan may look harmless to the eye, but suspicious to an algorithm trained on early tumors. A retina photo may reveal clues about diabetes, kidney risk, or cardiovascular stress. A heartbeat waveform may carry signs of future failure before the patient feels weak. The machine is not guessing like magic. It is finding statistical fingerprints that are too subtle, too numerous, or too fast for humans to notice. In radiology, AI can flag suspicious scans so doctors review urgent cases sooner. In eye care, algorithms can screen diabetic retinopathy from retinal images. In intensive care, predictive systems watch vital signs for early sepsis warnings. In pregnancy care, AI ultrasound tools can help estimate gestational age in places with few specialists. In neurological research, AI-enhanced blood tests are being studied for detecting Parkinson's risk years earlier. Medicine is moving from reaction to prediction. Instead of waiting for disease to shout, AI listens for the whisper. That single shift could change survival rates, hospital costs, and how early treatment begins. But the most powerful part is also the most uncomfortable. Sometimes the algorithm finds danger without being able to explain it in human language. It may notice texture, symmetry, density, rhythm, or microchanges invisible to ordinary inspection. To a doctor, it is a normal scan. To the model, it is the beginning of a story. One hospital can generate millions of images and records every year. Across the world, that becomes a medical ocean. AI can search that ocean in seconds. This speed matters because early disease is often a race against time. But AI is not a doctor. It does not comfort a family, understand fear, or weigh a patient's life story. The best systems work like a second pair of eyes. They warn, rank, compare, and suggest. The doctor decides. Yet, this technology has serious risks. A model trained on one population may fail on another. Bad data can create false confidence. False alarms can flood hospitals with unnecessary tests. Missed warnings can be even worse. And privacy becomes critical when health data turns into predictive power. This is why medical AI must be tested, regulated, and monitored after release. In the United States, many AI-enabled medical devices are already authorized by the FDA. Most are not replacing hospitals. They are entering quietly, one workflow at a time. The greatest impact may happen far from advanced hospitals. In places with few specialists, AI can help screen more people faster. A portable ultrasound, a retinal camera, or a phone-based tool can become a front door to earlier care. That does not solve every healthcare gap, but it can move the first warning closer to the patient. The next frontier is combining signals. Imagine one system reading your scan, your blood markers, your sleep patterns, and your medical history together. Not to label you sick, but to detect when your normal begins to change. This is the dream of predictive medicine. Treat earlier, intervene smarter, and prevent the emergency before it begins. But early knowledge can also be heavy. Would you want to know you may develop a disease years before symptoms? What if there is no treatment yet? What if insurance companies, employers, or governments misuse prediction? The future of AI diagnosis is not only technical. IT is moral. Healthcare systems are aging, overloaded, and expensive. Doctors need help finding the few dangerous cases hidden inside thousands of normal ones. Patients need faster answers. Hospitals need earlier decisions. And the world needs medicine that reaches people before crisis does. The strange part is that the earliest sign of disease may no longer come from the body alone. It may come from the pattern between a scan, a number, a heartbeat, and a line of code. That pattern may be invisible to us, but not to the machine. So the question is no longer whether AI can detect disease before doctors. The real question is whether we are ready for medicine that knows something is wrong before we feel anything at all. Because the next diagnosis may begin long before the first symptom.